Okay, today's 7-3 notes are over polynomials. We're moving on from the exponents, but we are still going to be using them. Polynomials are classified by their degree and their terms. Okay, so the first thing we're going to talk about is the degree. And the degree is determined by the term that has the highest exponent. So x to the 0th would be the 0th degree. X to the 1st would be the 1st degree. And we're going to do this all the way down. X to the 2nd is the 2nd degree. It's a 2nd degree polynomial. X to the 3rd would be a 3rd degree polynomial. X to the 4th would be a 4th degree polynomial, and I hope you're starting to get the idea. Whatever the power of the exponent is the power of the degree. And this would be the 7th degree. Okay, so next we're going to look at the name. Okay, so the name is determined by the number of terms in the polynomial, and my notes are not complete for some reason, so that's x to the 2nd power, this is to the 5th power, this is to the 3rd power. Your notes should be correct. This should be the 2nd power. Okay, so the name is determined by the number of terms in the polynomial. So 5x has one term, that would be termed a monomial. Mono meaning one, so monomial. 2 terms would be a binomial, prefix binomial meaning 2. 3 terms would be a trinomial, tri meaning 3. And then anything more than 3 we call a polynomial, poly meaning many. Okay, together the combination is used to classify a polynomial. So in example 1 here, classify each polynomial by degree. So we want to look at each of the terms and find the highest exponent. So the highest exponent is 3, so this is going to be a 3rd degree. And then we need to identify it by the number of terms. There's 1, 2, 3 terms. So this would be a trinomial. A 3rd degree trinomial. Okay, I need to move down. Okay, number 2, I want to look for the highest exponent. And it looks like 7 is going to be the highest exponent. So this is going to be a 7th degree. Then I need to count how many terms I have. I have 1, 2, 3, 4, so I have more than 3, so that's going to be a polynomial. A 7th degree polynomial. Number 3, I only have 1 term, and that exponent is to the 2nd power, so that will be a 2nd degree. And I have 1 term, so that makes it a monomial. Number 4, my biggest exponent is 1, so that's going to be a 1st degree. And I have 2 terms, so 2 terms would make it a binomial. Okay, going up to number 7. Number 7 does not have any exponents, so that would make it a 0th degree. Anything to the 0th degree equaled 1. And there's 1 term there, so it would be a monomial. Biggest exponent for my degree is going to be 5, so this is a 5th degree. And I have 1, 2, 3 terms, making it a trinomial. Number 7, my biggest exponent is 3, making it a 3rd degree. And then I have 2 terms, binomial. Example number 8, my biggest exponent is 2, so that makes it a second degree. And I have 2 terms, binomial. So we classify the polynomials by the biggest exponent, the degree, and the number of terms. Okay? Now we're going to be adding and subtracting polynomials. And we're going to simplify each problem and classify your simplified solution by degree and term. Answers need to be written in descending order, and the descending order means in exponential numbers. Okay, so adding polynomials is going to be pretty easy because it's going to be very similar to when we combined like terms. So I'm going to look, and I have 9r to the third power. So I'm going to look at all my terms with the third power. So I have a 9r to the third, and I have a negative 2r to the third. And I'm going to be combining those, and that gives me 7r to the third. Okay, then I want to look, and I've got an r squared, so I want to look at an r squared and see if I have any other r squareds, and I do. I have a negative 8r squared. So I'm going to be combining those as well. And I get 5 minus 8, which gives me negative 3r squared. And then I have one more term left. I have an 11r and I have a 9r. So I can combine those. And I'm going to have 20r. So I combined the terms that I have that were alike. And this is my simplified expression. Answers need to be written in descending order. So I do have it in descending order from r to the third, r to the second, down to r to the first. Okay, number 10, I'm going to be adding my exponents again, and one of the things you might want to look for is look for the biggest exponent first. So my biggest exponent is to the 5th, so I have negative 7x to the 5th, and I have another 5x to the 5th, so I can go ahead and combine those, and I get negative 2x to the 5th. Okay, then I'm going to look and see if I have any to the 4th, and I have 10x to the 4th. That's my only term, so I won't be combining it with anything. I'm just going to be bringing it down, 10x to the 4th. And then I want to look and see if I have any x to the third terms, and I do not. Then I want to move on to x to the second. I do not. So then I'm going to move on to x, and I have 2x terms. I have negative 2x and positive 7x. So I'm going to combine those, and I'm going to have 5x. And then I have one final term. I have my constant plus 14. And 14 is just going to be brought down, plus 14. So that's one way you can do to start with your largest exponent to begin with. And then move your way down the line in descending order. And I have negative 2x to the 5th plus 10x to the 4th plus 5x plus 14. Okay, number 11. Same thing, I'm going to see my biggest exponent looks to be x to the 4th, so I'm going to look at all the x to the 4ths first, and I have 2, and that's going to give me 2x to the 4th power. And then I'm going to move on to the third power, which I do not see any. I do have to the squared power, and that appears to be my only term. So I'm going to write negative 10x to the second power. And then I'm going to move on to my x term. So I have a 7x and a negative 14x. So those two will get combined, and I will get a negative 7x. And then I have one final term, which is my constant, negative 14. And negative 14 will be brought down. There's no other terms that I can combine with it. And then I've ensured that I've gone down in descending order. Now the answer also said to identify the degree and term. So I'm going to go back and do that. My highest degree is 3, so it's going to be a third degree. And I have 1, 2, 3 terms, so that goes back to our trinomial. My biggest exponent is a 5, so that's going to make it a 5th degree. And I have more than 3 terms, so that's going to make it a polynomial. And my biggest exponent is a 4, so that's going to make it a 4th degree. And again, I have more than 3 terms, so it's going to make it a polynomial. Okay, I'm going to move on down to subtracting polynomials. This is going to combine a little bit of the distributive property first, and then we're going to combine like terms. The distributive property is going to occur right here because in front of that minus sign that's like a -1. So that does mean I need to go back through and distribute that negative sign through before I can combine like terms. So that's going to give me negative x to the 4th plus 7x to the 3rd plus 3. So it is going to go through and change all the signs. And I'm going to bring down my 8x to the 3rd minus 6x plus 3x to the 4th. And just like before, now I'm going to combine my like terms. So I see I have an x to the 4th, that appears to be my biggest, and I have 3x to the 4th minus x to the 4th, so that gives me 2x to the 4th. Now I'm going to look and see if I have any x to the 3rds, and I do. I have an 8x to the 3rd and a 7x to the 3rd. And that's going to give me 15x to the 3rd power. And we'll see if I have any to the 2nd power, and I don't. Any to the single power, I do. I have a -6x, so that does not combine with anything. So I'm going to have minus 6x. Oh, it's not a 6x, it's just a 6. Okay, well, being that's the case, then I have a -6 and a +3, and that's going to make it a -3. Okay, go ahead and classifying it. My biggest exponent is 4, so it's going to make it a 4th degree, and I have 3 terms now, so that's going to make it a trinomial. Okay, number 13, I'm going to go ahead and distribute that negative through, and that's going to make it a +14, a -5p to the 5th, and a +11p to the 2nd. And I'm going to bring down my first part of the equation, 4p to the 4th plus 11p squared minus 9p to the 5th. And again, I'm going to look for my biggest exponent, and it's going to be to the 5th power. So I have a -9 and a -5, so that's going to give me -14p to the 5th. Then I'm going to move down to my p to the 4th. I have a p to the 4th here, and that appears to be the only one. And that's going to give me plus 14p to the 4th. I don't have any to the 3rd power that's left, but I do have 11p squared and another 11p squared, so that will give me 22p squared. And then I have my constant 14 plus 14. Now if I identify my degree, it's going to be the highest exponent, which is going to be 5, so this is a 5th degree. And I have more than 3 terms, so it's going to be a 5th degree polynomial. Okay, number 14, again, I'm going to need to distribute that negative sign. So it's going to be -3n squared minus 11n to the 4th plus 21. And I'm going to bring down my previous polynomial, 8n minus 3n to the 4th plus 10n squared. And I'm going to look for my largest exponent, and it appears to be to the 4th power. So I have a -3 to the n to the 4th and a -11n to the 4th, so that's going to give me -14n to the 4th. My next degree is going to be to the 2nd power. So I have a 10n squared and a -3n squared. And when I combine those, I'm going to have 7n squared. And then I appear to have an n term. It does not combine with any others, so I have plus 8n. And then I have the constant 21. And 21 does not combine with anything, it comes down. And my degree is going to be the largest exponent, which is going to be a 4th degree. And I have more than 3 terms, so it's going to be a polynomial. Okay, so adding and subtracting polynomials is going to be very similar to combining like terms. And with subtracting, you're going to use the